So electrolysis ठीक है, electrolysis can be divided into 3 categories, which are 1, 2, and 3. Okay, so over here the case is when it's molten. We did a few questions on molten so far. ठीक है, molten में कोई मसला ही नहीं है. There are 2 ions present, they both discharge. ठीक है, there's no competition, no nothing. Now the other thing is, aside from molten, they're in a solution. So let's call one a dilute or a regular solution, dilute solution or regular solution. As long as it doesn't have concentrated in its name, it's a dilute or regular solution. ठीक है? So that's one category. And the third category is concentrated solutions. ठीक है? So this is done. This is done and dusted. You guys, if you understand electrolysis, electrodes and cations and what's going to discharge, molten is done. No competition. Dilute में एक मसला है. Dilute में मसला है, let's say you're talking about sodium chloride. You're talking about sodium chloride. If it's dilute, that means it's aqueous. If it's aqueous, the ions present are obviously sodium and chlorine. But because of the water, there's also H plus ions present and OH minus ions present. Now there's a competition. You have to figure out between the two which will discharge, between the cations and between the anions, which will discharge. For concentrated solutions, it's exactly the same situation. You gotta figure out what's gonna discharge. Okay? You still have sodium, you still have H plus ion, same thing, but concentration obviously different, है ना? ठीक है? Now, let's talk about these two for a bit. ठीक है? हम anions, there are 2 lists given to us, right? One is the metal reactivity series. Metal reactivity series will deal with all cations. So we look at the series and we can figure out between the two which will discharge. It's just a list, and जो भी इसके नीचे होगा list में, the bottom will discharge more, is more likely to discharge, and it will. More often than not, it's just hydrogen. More often than not, but not always. ठीक है? Same over here. Anions, there's no difference between the anions for a dilute solution and a concentrated solution. ठीक है? But when you move on to anions, was I saying anions a second ago? I meant cations if I was saying anions, my bad. Anyway, for the anions now, the anions, the one with the negative charge, the response will be different. In dilute solution, you look at the anion reactivity list, जो आपको list मैं अभी दिखाऊंगा, उसमें से whatever's at the bottom, again, very similar to the cations, the ones at the bottom will discharge. Normally it's OH. Almost every time, 100% of the time, OH ions will dissolve, will discharge. ठीक है? But concentrated, that's not the case. You don't look at the list anymore. Whatever is more concentrated ends up reacting. And whatever, every time it's concentrated, it's always the ion present in the solution, right? Like the solution, not the solution. Whatever the compound is, it's NaCl, it'll always be chlorine that's concentrated. Sodium is also concentrated, but that doesn't really matter. But it's always going to be chlorine that will also discharge. Chlorine will be preferred more because it's in higher concentration. ठीक है? That's it. Like, why exactly? Is like, the reason for it is kind of, it's complicated. Like, there's an equation, there's a huge ugly equation, and you got to figure out, so there's a balance between like what works and what doesn't work. But like the easy way to kind of go around it without the explanation is just that chlorine is more likely to discharge if it's concentrated, or whatever the anion is, it's more likely to discharge if the solution is concentrated. Now note that they don't tell you the concentration. What is technically concentrated, right? Is it 1 mole per decimeter cube? Is it 2 mole per decimeter cube? Is it 20,000 moles? You know, like, they don't tell you. So what's the fine line between when NaCl dissolves or NaCl, well, when chlorine will discharge and when it won't? What is that point? They don't tell you, and it's not expected to be known. It's just that it's an exam thing. It's not even a science thing. If it says concentrated, just take the anion and that'll discharge. Ignore the list. That's your thought process. Because we don't go into too much detail. It's a very on the surface exposure to electrolysis. ज़्यादा detail में जा भी नहीं सकते because it gets complicated. ठीक है, let's move on. This entire discharge thing I'm talking about is known as the selective discharge of ions. We have to select which ion is going to discharge at the cathode and at the anode. Amongst the four, the two will discharge, will go to the cathode and two will go to the anode, but only one selectively will discharge and not the other. Okay? So we're going to talk about selective discharge of cations, selective discharge of anions, and what effect concentration has on the selective discharge. Well, I've kind of practically told you what this is, but we'll reiterate in the coming slides. For the discharge of cations, we'll borrow a list from another chapter. This is called the metal reactivity series. This is the most reactive metal, and this is the least reactive metal, and everything in between follows that trend as well. From left to right, you're going, the reactivity decreases. Okay? Now, this list is normally vertical. I didn't have room, so I kept it horizontal. But normally you say down the reactivity series, reactivity is decreasing because potassium should be on top, then you have sodium and potassium and magnesium and aluminum all the way, right? So it's seen as vertical. Just try picturing it vertical. Okay. Sorry, I didn't have enough room. It wouldn't look as pretty, I guess. Anyway. Okay. Now, if you have to figure out what's discharging, let's look at the same example we were talking about. Sodium chloride. Aqueous. जब अभी cations की सिर्फ बात हो रही है ना, I'll just talk about the cations. इस solution में cations क्या हैं? Well, there's sodium ions and hydrogen ions. ठीक है? Between the two, which two will discharge? So you have to memorize this list, and in the list you'll go, okay, sodium is over here, and hydrogen is over here. What's this line saying? Ease of discharge increases. Now I said about reactivity. But ease of discharge will increase as you go down the list. I'll say down, but I mean left, right? Like, I'm just confusing my words now. Okay. But down the list, this is the side being down and the side being up. Down the list, hydrogen's way at the bottom and sodium's way at the top. So ease of discharge is increasing as you go down, right? As you go down. So ease of discharge is increasing. So what's going to discharge? Hydrogen, because the more down the list or the more right of the list you are, it's going to be more easily discharged. Okay? So between the two, hydrogen is more likely to discharge because in the list of reactivity, the reactivity series, it's way at the bottom. And if they ever ask you to justify it, that's exactly what you say. Okay? So hydrogen will discharge and produce H2 gas. And that's how you use the reactivity series. Let's do one more example. What do we have? Here's an example where hydrogen doesn't normally win. It's copper sulfate aqueous. We don't care about the sulfate ion too much. We're talking about ions. Is aqueous solution mein. The ions are going to be Cu2+ and H+. Okay. Between the two, what will discharge? Let me highlight the two. Hydrogen is already highlighted. Let me highlight again in blue. I almost did it on top of it. And the other one's copper. Will it matter if they're right next to each other? Absolutely not. It doesn't matter. But copper is lower, quotation marks, lower in the list. Okay? So what do you think is going to discharge? Copper is going to discharge before hydrogen. Okay? So the cathode will see copper being deposited and the electrode it's not going to turn into gas and fly out. It's at room temperature. So it's not like hydrogen. So cathode is just going to start forming at the electrode. And hydrogen is going to do nothing, stay in the solution. A bit of reading. Ions of the reactive metals like potassium and sodium will remain in the electrolyte solution and will not discharge. Why? Because they're at the very top of the list. You don't normally see, like, they'll normally won't discharge. It's very unlikely that they will discharge in a solution. Hydrogen ions and ions of less reactive metals like copper and silver will be more preferred when it comes to the discharge. Okay, and it's just reiterating the same point in slightly different words. Let's move on. Now this changes how you're looking at the reactivity series. So because it's always aqueous solution, So the battle is between hydrogen all the time. So it's either with hydrogen and some other metal. So you can remember the reactivity series as hydrogen is in the center and there's all these metals on top of it and all these metals, very few of them actually, at the bottom. And they're also in the reactivity series given to us, it's not complete, some more dangerous elements like rubidium, radioactivinium, that's not a metal, aren't present because you normally don't see them in a chemistry lab. It's only the reactivity series only has the most probable list of elements present. Okay, so it's an incomplete list. There are more other metals, but we don't care too much about it. Okay, hydrogen. Hydrogen ions will preferentially be discharged over the ions of metals above hydrogen in the reactivity series. Hydrogen gas will be liberated when it is discharged. Likewise, if the cations come from a metal which is below hydrogen, they will preferentially be discharged and hydrogen will not be liberated. It's the metal that will be produced. Okay, let's move on. Let's do these questions together. I'll just you pause, you do the questions and you watch me do it. Okay. Now if you want the steps are identify the cations and anions, right? Now highlight what's going to the cathode and what's going to the anode. That's step 2. Step 3, figure out what's going to discharge at the cathode using the reactivity series. Okay, reactivity series. Let's try doing that. We're only talking about the cathode for now. So let's see, because we haven't talked about any of the, anions. Anyway, so this is easy. So all these solutions will have H plus ions if they're a solution. If they're molten, they won't have water in it because it's just piglava. There's no pani in it already. The sodium solution will have Na plus and hydrogen. Molten sodium iodide will just have Na plus. Copper chloride solution will have copper 2 plus, I think. And well, I'm just confused with the charge. Take a 2 plus ही होगा. And it doesn't really matter. We're just talking about the product, right? So you can say 2 plus or 1 plus. Doesn't matter. Okay, dilute hydrochloric acid. Well, it's just H plus because there are no other cations. Both HCl will produce H plus ions and water will also plus H plus ions. There's only one. Magnesium sulfate solution. Magnesium sulfate solution will have magnesium ions and H plus ion. Why am I talking like that? And sodium solution again will have these two ions. Okay. A line, and let's figure out what's going to discharge and what the product's going to be. Okay. Between the two, sodium and hydrogen, hydrogen's at the bottom because posoka, so is the second, hydrogen's way at the bottom. So hydrogen's going to discharge, and when hydrogen discharges, H2 gas is formed. For the second one, there's no competition. It's only sodium, so sodium metal will be formed. Okay? And the third one, copper is below hydrogen, right? Because it's hydrogen. We just did a question where copper was right after hydrogen. That's how I remember it. Otherwise, I would have to look it up. So what's going to be produced is copper metal. Dilute hydrochloric acid, there's no competition. It's just hydrogen, so H2 gas will be produced. Magnesium sulfate solution. Well, where's magnesium? I think magnesium's pretty sure is higher than hydrogen. Oh, so I highlighted the wrong one. Hydrogen will be released. Okay? And in the last one, it's again the same as the first one. Hydrogen will be react and produce H2. Okay, straightforward. Let's move on. So did we talk about cations? Yes, we did. Now we're going to talk about anions. Now anions, पूरी दुनिया के anions नहीं लाते. There are very few. We start with the sulfate ion, then we have the nitrate ion, then we have all of group 17. Well, not all of it. The three most charming anions are like ions from group 17, chloride, bromide, iodide. In order, so you start with fluorine in group 17, then you have chlorine, bromine, iodine, and astatine or whatever. But these three are probably the most important. Fluorine, I think it's too reactive. So you just never put it in the lab. So it's like almost dangerous levels. I don't know why you never discuss fluorine. That's probably why. And to top it off, or so to speak, you have hydrogen, or hydroxide ion, right at the bottom. Okay. Now again, sulfate and nitrate, they're just so high up there, they're never gonna react. They almost never do, so their product is even missing there, right? Okay. They don't even bother writing what the product is. For chlorine, if it discharges, will be chlorine, bromide, bromide ion, it'll be bromine, iodide ion, iodine. By the way, a lot of people don't know this for reasons, or like, I think it's the chemistry teacher's fault, they never teach it. Chlorine means the chlorine element, whereas if I say chloride, it means the ion, so आपके toothpaste में fluorine होता है या fluoride होता है? Fluoride होता है. So that means in your toothpaste you have fluoride ions, not fluorine. ठीक है? One could kill, the other is good for your teeth. ठीक है? Just saying. Alright, so chloride means every time it's a "ide", it means the ion. ठीक है? Now notice one thing, more often than not, it'll always be the hydroxide ion. When in doubt, I guess, just don't go with the hydroxide ion because it's the most likely to discharge. But the only caveat is, remember the concentration wala? If it's concentrated, then it's not hydroxide. It's whatever the other ion is. ठीक है? Let's take a look. In the discharge of anions, it is important to note that the anion in higher concentration is always being preferentially discharged regardless of the ease of discharge of anions. Fancy words, लेकिन ये बोलना चाह रहा है कि concentration जब ज़्यादा हो तो anion का कोई कुछ नहीं बिगाड़ता. Anion will be whatever. It's same for dilute or concentrated. Cations में बिगड़ जाता है, right? It'll only be the concentrated, whatever's in higher concentration now, that'll discharge, and not hydroxide ion, which was, I think it was going to. ठीक है? Let's move on. To summarize, this is a reiteration of the steps I mentioned when we were doing the skill check earlier. To identify the cation that will discharge in the aqueous solution, refer to the reactivity series. The lower of the two cations present will be discharged. The anion that will discharge will also be the lower in the list we discussed earlier. So anion ki list with the sulfate and the nitrate and the chloride, bromide, iodide, and hydroxide. ठीक है? उस list में whatever's at the lower end will be discharged. For the cation, you will be referring to the reactivity series. If the solution is concentrated, the anion in higher concentration will be discharged. ठीक है? The charge with the negative one will be discharged. Nothing about the cation. ठीक है? So doesn't count. Let's take a look at the next set of questions. Okay, same set of questions, but we're now talking about the anode. Note, nothing over here is concentrated, so we don't have to worry about that for now. Okay, let's highlight all the cations. Iodide के solution में, so all the solutions will have OH minus ions. Let me just, यहाँ पे नहीं है, यहाँ पे OH minus है, dilute है तो OH minus है, magnesium sulfate है, OH minus है, OH minus है. Now OH minus is right at the bottom of all of those lists, and none of these are concentrated. So सब में OH minus ही होगा react and will give you the, what do you call it? Because it's at the bottom, it's at the very bottom OH ions, na? But let's do it anyway. ठीक है? The other thing is you have iodide ions here, you have, except this one because it doesn't have OH. Iodide ions here, you have chloride ions, you have chloride ions again, you have sulfate ions, ठीक है? And then you have hydroxide solution. There's no other ion over here, ठीक है? Because it's sodium hydroxide. So the ion being discharged for all of them is just going to be this guy, except over here it's just going to be ion. So we're producing O2, we're producing I2, we're producing O2 again, O2 again, O2 again, and O2 again. ठीक है? I hope this helps, guys. Really long video, but these are probably the most important slides in electrolysis. Once you get this, everything else is just a piece of cake.